Good morning. So let's review the problem that you were working on. Now, the basic idea behind this is that you're constructing a parallelogram, and the parallelogram has to be constructed using math tools. The information that you've been given so far is that you know that the parallelogram must have a 6-meter side, a 5-meter side, and a 40-degree angle. Now, because we can't draw 6 meters and 5 meters on our paper, we're going to have to use some type of a scale relationship. So ideally, the scale relationship in this case would be 1 meter equals 1 centimeter. That makes the most sense for now. So that means your 6 meters should be represented as 6 centimeters. And your 5 meters should be represented as 5 centimeters. The 40-degree angle we're going to maintain and keep as is. Now for this activity, I'm just going to show you using your compass, and I'm using a pen because the pencil just doesn't seem to be picking up with the video. So as long as it's balanced, the pointer and the contact of the pen, it should still work. So I'm going to tighten that down. Right's fine. Good. Perfect. So the first thing I want to do is make sure I've got enough space. I'm going to be drawing a parallelogram. Now parallelograms have 2 sets of parallel sides and it's slightly slanted. So this is my estimation. This side matches this side as far as length is concerned. This side matches this side as far as length is concerned. And in my diagram, the longer side length appears to be the 6 centimeter side on the bottom. And this was my 5 centimeter side on the sides. So far so good. I'm hoping this will be a 40-degree angle in my plan, and I'm going to start to create that right now. So I take my ruler and I'm going to mark my 6 centimeters, just like that. Put that aside. Take my protractor, putting the vertex of the protractor on the end of the line, starting with this arm counting at 0 up to 40 degrees, mark, straight edge, connect the end of that one line all the way up to and through the point. Double check with your protractor. 40, that's good. Second step. This side length has to be 5 centimeters. So I'm going to take my ruler, set it on the 0. Oh, now that line I drew is a little bit too long. I wanted to stop it at 5. This is why using a pencil is better, but for this video, I'm just going to use a pen so that you can actually see the lines. Okay, so my 5 centimeter mark is right about there. I'm going to call this point point C. This point I'm going to call point B. This one I'm going to call point A. So far so good. Now I'm looking for point D, which is somewhere over here according to my plan. So in my estimate I had A, B, C, D. Now D is going to be tricky to find. Tricky because I don't know the angles, and I do know the side lengths though. So when you know the side lengths and you don't know the angles, my recommendation is go with your compass. Now we've already measured on the paper. So what I'm doing, let me clarify so you can see it better. Put my pointer on the 0 and set the tip of your pencil or your pen to the 6. Why? Because I need a 6 centimeter gap. And double check it. Okay, got my gap. Now, the reason I'm doing 6 centimeter gap is from point C to point D there should be 6 centimeters difference because it's the same distance as side length AB. Good. So I've got my arc. Next step, adjust. Now the other side length was 5. So I need to make sure that this one is also 5. Now the difference here is that I'm going to be putting my pointer on point A rather than point C. Why? Because the space between the pointer and my pen should represent the 5 centimeter side length, not the 6. So then I draw my arc, and I have a nice intersect point. Now that intersect point represents point D. Right there. So then I can use my ruler to double check the side lengths. So this one should represent 6 centimeters, and it does. And this one, you'll notice that side length CD is parallel with side length BA. And then AD, 5 centimeters. Now we have to check with our angles and our side lengths. So still pictures of the side lengths using a ruler make sense. We double check this angle is 40. Double check, okay, this angle should also be 40. This length here, this angle here for angle BAD should be complementary angle of 140. And then angle BCD is also complementary angle of 140. So how do we double check even further? Well, we know the total internal angle of any polygon should be 360 degrees. We know that this internal angle is 40 degrees. We've just proven and measured that this one is 140. And we've proven and measured that this one is 40. And this one is 140. Now if you take all those angles and add them all up, 140 degrees plus 140 degrees plus 40 plus 40, you should get a total of what we have. Let's consider grouping. So we've got 4 groups of 4, so count by 4s carefully. Did you get it? Awesome. Now we have to regroup, or we have too much to 10 call. So regroup 1 and then add your hundreds. Does this make sense? Any mistakes? Okay, how can we solve it? Okay, how can we solve it a different way? Well, if we know that this angle is 40 because we measured it, we know this angle is 40 because we measured it, what if you did 360 degrees, take away 80 degrees, which would be the two 40-degree angles we've already checked? Well, 6 can't take away 8, so we regroup. We have 280 degrees left. That means when we take the 280 degrees, divide it in half, we should get the angle for each. Angle C and angle A. They should be half of 280. And half of 280 degrees is simply how much? You get it? 140. And you can double check it by saying 140 times 2 and running that calculation as well. So this is how you construct a parallelogram when you're given a side length, and an angle using math tools.